All right, good morning, Logan. It's Thursday, March 19th, and it's time for another math lesson. So, I have no idea what's happening for the next week, 2 weeks, 3 weeks, months, even the rest of the year. But what I do know is that regardless of when this ends, you plan on moving on. Some of you plan on going to the next level math, in which case, a lot of the stuff that we're discussing is going to be useful to you. The good news is the most important stuff for Algebra 2 has already been discussed. Okay. So if you had done well on that test, which I have not graded yet, I'll get back to you as soon as possible, then I would say you're probably good to go for that next level. But until then, until we figure those things out, what I want to do is I want to take a look at section 6.2, which is on the properties of parallelograms, and I want to keep moving this discussion of the four-sided shape of the quadrilateral. Okay, so yesterday, or 2 days ago, what we talked about, there were a couple of properties. First is understanding what a parallelogram is. So oftentimes you'll see people draw parallelograms with kind of like slanted lines. All right. Now this is a horrible version of a parallelogram because it doesn't look like the lines are parallel or the sides, opposite sides are parallel, but in fact they are. So we have opposite sides are parallel like that. Now what we said yesterday, or 2 days ago, sorry, is that opposite sides, there and there, those guys are not only just parallel, but they're also congruent to each other. And then we can also say the same thing about those two sides right over there, is that they are opposite, those opposite sides are also parallel, but also congruent to each other. And then the second property that we said is that the opposite angles are congruent to each other. So those sets of angles, the opposite ones are congruent. So those two guys there and those two guys, oopsies, those two guys over there, they're congruent to each other. The last one, and this is the one that a lot of people have been having questions on, is that consecutive interior angles, or angles that are adjacent to each other, are also going to be congruent. Sorry, my mistake, not congruent, are also going to be adding up to 180. So if you had something like 75 right here, then that would mean that the angle that is consecutive to that would also add up to 180 with that. So this guy right here would have to be 105. But not just those two have to add up to 180. These two also have to add up to 180. So this would come out to 105 right there. But not just these two and these two, but also these two. These two angles need to add up to 180, so this would be 75 there. But not just these two and those two and those two, right? So it's not just 1, 2, or it's not just 2, 3, or it's not just 3, 4, but it's in fact also 4 and 1. Those two angles must add up to 180. And that right there was the last property. It's a little more complicated, but it is the property that allows you to do that really that problem that had the letters B, C, and D in it, had the three different variables. What you want to do is you want to set up your equation. Okay, so for this last property, I have to introduce a new set of lines, and they're called the diagonals. So we have this line right here. So when you connect two vertices, two non-adjacent vertices, what you get is a diagonal. But we have more than just that diagonal. We have a second diagonal. We have this diagonal right here. Now, what's interesting about these two diagonals is that the property, this is your next property, this is property number 4. What this property says is that the diagonals bisect each other. Diagonals bisect each other. Bisect each other. A lot of people will just say, oh, that means they're in the middle. And exactly, they hit each other at their middles. But that's where it can get kind of complicated, kind of goofy. So what I want to do is I want to break this thing down. I'm going to write down some names here. So we're going to call that guy A, and then we got this guy over here is B and C and D. But now we have a point of intersection. I'm going to call that, because you thought E, I'm going to call it M. And what happens is M is the middle of the green line, but it's also the middle of that pinky orangish line right there, the salmon line. So the idea is you can now say that we know that AM, right, segment AM is congruent to segment MC. But that's not the only thing we can say, because that's just for the green line. We can also say the same exact thing for that orange line. We can say that BM is congruent. BM is congruent to M. Oh man, that's an ugly congruent line. BM is congruent to MD. So let's suppose I knew that MD was 8 and MA was 7. I can now say that I know what MC is. MC must also be 7 and MB must also be 8. All right, Logan. So this is a very short video. I just wanted to do this last property in there. So you have an assignment today. Please take a look at it. I know it's still having, it's still that spring break feel, but I do need you guys to start thinking about a little bit of math, keep you on your toes. Um, have a good day. I'll try to get back to you guys tomorrow. If you have questions, please text or email me, and we'll try to see if we can set up either a Google Hangout or something kind of along the lines of Zoom. All right. Keep safe. Keep your 6 feet away from everyone out there, and please try to stay home. Don't go out. Keep the community safe. All right. See you later, Logan.